I think we're probably going to have to use our doorstop here. So I've just bolted it down. Frigging's half seized. Wouldn't expect anything less from one of these. Well, g'day, Max here again. Welcome back to the shop. So, actually a nice warm morning out there for 7 AM. It's 15 degrees, which is like quite a bit warmer than it has been. So what we're going to do is get into the longer trapezoidal threaded rod. This is the vice clamping screw for the Kasto Power Hacksaw. So we'll bring you down and go through our plan. So this is the new piece that we have to make. Fair length of trapezoidal thread, M28 by 5mm pitch, parallel section on the end with a 20mm thread, and there's a bit of a head on it, quite a deep keyway with some retaining screws to hold a captive key. So we're going to make our new one out of 4140. We'll get the material. This piece already has a piece turned down on the end from something else, but it's still just above the required finish diameter that we need here, so we'll be okay. Screw cutting this, yeah, well, it will be a bit of a challenge, but we'll see how we go. Ideally, if we were able to get 1144 stress proof here in Australia, I would make it out of that, as I think it's quite a free machining material compared to this 4140 bar stock we have here. And we've broken out the Great Australian doorstop to assist us with the machining. These things are not a thing I use very often. In fact, mine was seized up. I had to pull the fingers out and free them all up and re-oil everything. So this will be the first time we've used our doorstop on this machine. And realistically, we're only using this because we're cutting a left-hand thread. There's a fair chance if we were doing a right-hand thread, we wouldn't be using this at all. I'd use a different technique. So anyway, let's get our material set up. During the cleanup, I just remachined the face of the fingers. These are cast iron tips on it, and I just cleaned them up with an end mill to make them flat, then filed a good chamfer on either side. That way, if we're coming up to any weird steps in the machining where the thing wants to grab the part, the chamfer gives it a little better chance of riding up over any burrs or anything like that. Okay, so I've just put a mark in with a texter so I know how far up the chuck I can poke this bar to allow us to machine our full part. Okay, so I've got our bar clocked in reasonable enough. We're lucky I already had a centre in the other end of it. This bar does have a bit of a bend in it, hence I have some aluminium shims under the jaws, and they're not in there very far, so the jaws don't influence the bend in the bar. You see them there, they don't go in very far, just to keep that influence to a minimum. Okay, let's see if we can get our groove in without too much carry on. Right, well that's our starting groove, our relief groove for the thread. It's where our tool will start from. So I'll just check that diameter. Should be, we should be about just under 22.5. 22.4 would be good. Ah, 22.45, that's good. That's that puts, if our tool touches that when we're cutting, that gets us just under 0.05 millimeters under the maximum root diameter. But yes, I do have reservations about the required finish that I'm chasing, that, you know, compared to what we can actually achieve on this material is 4140. So we'll just see what happens and see how it goes. So we'll get this blued up, we'll take a scratch pass, check that we are cutting the correct TPI. Sorry, the lighting's going to be a bit shite, but it's a pretty high intensity light on this and it does blow things out. And then we got the added shadow from the steady, travelling steady to get into the mix there. Okay, that should be enough. Some might immediately think, well, what's this banana doing? He's got the wrong tool in. Well, you'll see why as we progress. Looks like we are 1, 2, 3, 4, 5 pitches. 5 fives is 25. So we're all good there. So I'm just going to go in a bit deeper, run a cut through, and then take a second scratch pass. It'll look a bit weird, but I'll explain it once we're there. Okay, I'm advancing the compound 3 millimeters. 1, 2, 3 millimeters is there. Okay, I'll take my second scratch pass. Okay, this defines our playground with some safe boundaries. So I tried to mark it in black there, it didn't really show up. Okay, so these skinny lines here, we can do whatever we want inside those boundaries with the tool that we have in. We cannot encroach into this area. Likewise, this one here, we can do whatever we want in, and we can't encroach into here. So here is the crest. This will be a root, crest, root. Now I've left enough width there because we don't know how this material is going to react with the tooling that we're going to use until we go to do it and seen the damage done or not. So yeah, so we're going to rough this thread out with that 60-degree tool. Well, wouldn't that rip your undies? We're probably 50mm, 2 inches before the finish of that cut. And the Kennametal insert, we lost part of the end of it. Now this isn't not a new insert, it's an old one, and it came on another piece of tooling that I brought off eBay. So look at that, the whole side of the insert just dropped away. So I could have had a previous crack on it, been donged around in an old piece of tooling that I got off eBay from USA. So we don't know what sort of a miserable life this insert had. Unfortunately, yeah, if it was just the tip that fell off and not the whole half the side of the tool, I would have just ground a little flat on it, put it back in, and as we're only roughing, we'll just keep going. But yeah, it's okay, I've just been poking around in there with a file. I'm pretty confident I got the broken piece out, so we should be good to continue. We'll just have to reset up with another tool. Right, well, we've reset to a high-speed steel. That carbide one would have done well if the end hadn't have fallen off it, and even with the reduced clearance on the leading edge that it would have had as we were going deeper this side here. That, you know, you can sort of get around that just sidestepping the tool a bit toward the trailing edge, and that would have worked fine. But yeah, unfortunately it was my last left-hand insert, so we've got a high-speed steel tool in here, so we'll rough it out with this. I had to slow the lathe down a fraction, down to, what are we on, 112 RPM. We were on 160, but now we're getting a bit deeper, a bit more tool contact. Yeah, she wasn't happy. So what I'm doing is I'm just alternating, taking a bit off this side, taking a bit off the leading edge, a bit more out the centre, a bit off the trailing edge. I'm just alternating, you know, moving the tool around in different width locations according to my depth. So that, what I'm hoping to gain with that is to see how the material reacts. I'll just bend the camera around. Apart from the fact we need to reduce our tool pressure and, you know, to relieve any chatter. On this trailing edge, this is the most difficult face to get a good finish on. So now is a perfect time too to start. It's starting to clean up, but it was a lot rougher than that. So yeah, we're just seeing how this tool goes with a flat geometry on the top. You know, worst comes to worst, when we do our cleanup, we do it with two tools with a bit of side rake, you know, on the top involved. So we'll keep on going down. We're coming up, we're pretty well halfway to depth now, so I'll bring you back when we're a bit further into it. Well, the preceding cut to that lot there went perfect. We were just taking a bit right out the root, and then it started to gouge into the sides. And I just looked at my tool with a magnifying glass, and it's worn away the end of the tool. It's radiused it off. So I'll take the tool out and just touch up the nose of it. So we just sat the whole tool block in the tool and cutter grinder and just took a bit off the top of it. That's enough to clean it back up. Okay, I'll bring you in a bit closer and show you what I'm doing. Okay, well, several moments like that later, just indiscriminate times where the tool wanted to do that, just grab it. And bearing in mind too, I was never cutting on both sides really when that happened. It was either on the nose or on one side. So what I'm doing now is I'm widening our thread out, so you can see that shiny line there. Well, that's not to full depth. Full depth is below that. So that's my depth of cut at the moment, and I'm just taking the thread a bit wider because I want to get in there and get that root down to finished depth. Then I can get in there with a tool with a bit of side rake on it. So there'll be a left-hand tool and a right-hand tool, and then hopefully we should be able to get around this issue, because yeah, it's not forgiving, this 4140 material with a flat top tool. You know, it's pretty gnarly stuff. So yeah, I've got a lot of small cuts to do, so I'll bring you back when we made a bit more progress. You know, using a leaded steel for this application would have been fine, but that would have just been too easy, wouldn't it? Yeah, well, if all this goes pear-shaped, we will be using a leaded steel. But we'll try and save it. Okay, we've caught up on that real raggedy bit of the trailing edge, stepping the cut across. It's still raggedy, but nowhere near what it was. So now I can move the tool over. I'll probably take a bit off the leading edge now, and then I'll go back to cutting in the center to bring us to full depth. So I'm going to need to pick up on the cut on the leading side of the thread. So I'll still go in the same depth as we were. So we're 2 millimeters in. I've got an indicator on the, I'll show you. So I'm just using a combination of the indicator and my compound slide dial just for my left and right shifts towards the trailing edge or away, or towards the leading edge and away. And my indicator here is just a bit of a backup in case something, the knob moves down here or something. But so yeah, we're 2 millimeters in. We've got between, we could probably go another 0.75 of a millimeter, but we'll probably end up pulling up just shy of that. So yeah, what we'll do now is we'll get the cut done and I'll sneak the compound over and we'll pick up on the leading edge of the thread. So our tool at the moment, I've brought it back, so we should be centralized in the middle. So I'll take a cut and we shouldn't see anything come off, and I'll just start sneaking the compound across till I get till we get a cut happening, and then I'll start the cut from scratch again. Okay, that's not too bad there. We've picked up on it. Actually, we're probably about 0.5 away from where we were. So I'll start the pump, coolant, and we'll let this cut run all the way across. Just relock my compound. Start the coolant. Away we go. Okay, so we've just been nibbling away at the leading edge on our thread, and it's starting to come into where I want it. I'll zoom it up, zoom you in. Yeah, we're slowly picking up on the finish on it. One or two little gnarly spots, but they're very minimalistic. So what we're going to do now, I'll zoom you back. I'll change our tool out. Actually, I won't. I'll run this tool a bit further. I think we're going to be pretty clear now, so I can take this root to finished dimension. So I have about 0.6 millimeters, 25 thou to go, and then we'll finish the edges. Like the leading edge here doesn't need very much at all, but the trailing edge, that needs a fair bit of attention, and then that'll bring us that'll widen out this root and bring it to match the crest. Yeah, so thread depth is controlled because remember we turned this section here to the correct minimum diameter on the upper level of tolerance. So once we hit that and our tool's nibbled out a little bit down the root there, we know we don't have to go any deeper, and then we can just start sidestepping to our width till we get to our required pitch diameter measured over wires. And we also have a sample too to screw it to, so we're in a good spot. So yeah, I'll as soon as I've nibbled a bit away on here, I'll bring you back when we're trimming up the trailing edge, because I'm going to use a different tool. I'm going to use a tool with a bit of side rake on the top, just to try and get that bit better finish. As like a tool like this, I'll get it in the slot, but because of the lead angle on the thread, it's like way past a negative rake, and that's what's given us, well, that's why you get such a crap finish. So a bit of side rake will alleviate that, and we'll try and at least get it back to a neutral rake in relation to our lead angle. So we'll do a couple of spring passes now on that root diameter. Because we've had tool changes, you can't rely 100% on your dial, but we can rely 100% on this diameter here. Okay, so they won't require any more passes over now, as, zoom you out a bit, when we're doing the sides, our tool will be touching on that root, so if it needs a couple of thou here or there, well, that's when that will happen. So I'll get set up now, and I'm going to start tidying up the flank, the trailing edge of the thread, so I'll use a different tool. So these are the tools I'll be doing to finish off the trailing edge and the leading edge. So this, I can dick around with each face independent of each other, and they have a side rake ground on them. This has a 5-degree side rake, and this has an 8-degree side rake, and they're different because of the lead angle, the 3¼ degree lead angle of the thread. So that gives us, they'll be equally then approximately 5 degrees of side rake. So side rake only, nothing, no back rake whatsoever across the top here, because that way we maintain our 15-degree angle on the face. But on the top here we've got side rake. So if we take an end view, we're 5 degrees angled back there. Now that was put in such a fashion that it does not affect our 15 degrees. So if you go back to an earlier video, a couple of videos ago, where I was grinding lathe tools on the tool and cutter grinder, you'll see the method that I used and how I grind the clearance angle on this face without altering the 15-degree angle on this face here, the cutting edge. Well, I use the same procedure to do this side rake. So no back rake, which would be angled back here, because that will change your approach angle on your tool with the tool held in a horizontal position. So we'll get these in and we'll get trimming up these sides. So our trailing edge there is starting to clean up quite good now with that tool. You can see that little spot down there. Well, we're still on our way down to the root diameter, so we've still got a bit to go to take that corner out there. But yeah, no, it's just cleaning up quite well. So we'll keep going. Well, the thing was cutting along perfectly, and then just out of the blue for no reason, had a massive dig in, just straight out the blue, crack, and took the corner of that tool off. Bloody thing. So I'm going to have to pull this tool out, grind some off the top to reinstate this edge, and see if we can't rectify this mess here. But yeah, just no reason, straight out the blue. And that's after several cuts, all running the same, everything running perfect. So check this out. And that's with the steady rest not touching it. So that's possibly, if this bar's starting to move around, I've had a couple of little dig-ins like that big one we just had there, just totally unexplained. Okay, just running this indicator up and down, we've found the high spot in our bend, which is right here. So I want to just mark that. Just mark 12 o'clock on the chuck. We'll just get a Sharpie mark right there. So I'm going to give this a bit of a shove that way. You know, I'm just going to change out this tailstock centre. Yeah, I just put an old one in there. I don't want it to do anything funky to my good one. So our high spot's right here, so if I push, it's 0.4 millimeters. That's taken 0.5 millimeters out of it. That's helped a lot. Our high spot's changed to, that was our high spot on the indicator side, and that's our new high spot. Oh, just move along a bit. Might have been on a bit of a burr there. Okay, we're 0.12 millimeters. Oh no, our high spot's still in the same spot. I think it was just riding up on something. Okay, I'll just muck around with this off camera and I'll bring you back when we're at our best result. Okay, 0.12, that's as close as I can get this thing. If I try and improve on that, it gets to that point and then it goes a long way, like it drops its guts and goes somewhere else. So 0.12, that's probably about 5 thou, but it's quite easily to, you know, that's just moving it with my fingers quite easily. So I think that's as good as we're going to get. Right, we'll carry on. Well, we made it. Flank side, trailing flank, all cleaned up, and we're at depth. That's the hardest part done. Yes, I'll say that wasn't an easy task to bring all that back from bent back to where we have it quite good now. And I mean, that drained most of the resources out of my knowledge and experience, but we got there. So yeah, as we said, we'll get the other tool set up. We'll start working on the leading edge. Now, realistically, the leading edge should be a lot easier to tackle than the trailing edge. As I've said before, due to the angle of the thread, the lead angle. So I think what would be really advantageous is if the travelling steady had an extra leg coming up from underneath as well, and I think that would, that would change, would really enhance the performance of these door stops here. You know, that would really hold the bar nice and stable, especially on these long slender parts. So in the end, the trailing flanks of our thread, this area here, came up very well, and we are down to depth. So we had a good match between our flank and the root, so that's all come up well. The crests here, we'll just give them a bit of a tizzy up at the finish. Yeah, just coarse file marks from when we were roughing the thread out earlier on, just to keep all the burrs in check. So, all good there. So we're just into the leading edge of the thread now. I'm cutting along on probably about a good 3/4 depth, and I'm just sidestepping the tool across in that direction. And then I'll get a couple of measurements on the pitch diameter just to see how we're travelling. So I'll just put this clip in because the next remaining passes are going to be just nibbling away, and I'll bring you back after this cut for the finish cuts. So far we've sidestepped across 7 thousandths of an inch. And just checking pitch diameter just with one wire. We'll check it later properly with 3 when we're closer, but just going over one wire. 0.2 millimeters, 0.19, 0.2 millimeters to go. So about 7 or 8 thou-ish. So I'm just taking 1 thou cuts on the compound, moving the tool towards the tailstock, just keeping everything light and small so I'm not getting any flecks or any issues. Okay, that last cut was at depth and it's looking like we've caught up on our corners. So I'm going to come in, do a spring pass, check our pitch diameter, and if required we'll start doing a little bit of side stepping. Well, according to this, we've got 0.1. About 0.1 to go to hit our pitch diameter, which is 4th thou. You know what I might do? I might just I'll grab our nut, we'll have a test fit, I think, just to see, to be sure. Swivel you around somehow. So if our tool's clear, yeah. That's just our steady rest bopping over the thing, the tops of the threads. Low. Yeah, I think we're going to have to go a bit more, but I just want to make, oh, maybe not. Shit, that's not bad for a first test fit. Do you know what? I'm going to put a bit of oil on that. I think it needs about 1 thou off it. Yeah. Marvellous fit. Okay. Right, second test fit. Bear in mind, we haven't done any deburring or anything on this thread yet, so She's getting there, just needs a bit more clearance. There we are. It took another 1/2 thousandths of an inch off. Couple of tighter spots. But even, you know, there's zero. There's nothing in this. It's probably one of the closest fitting threads of the style I've done in my life. Just move the camera. True test will be when we tip it out, go the other way. Realistically, this should still have another thou clearance in it, at least, you know. Yeah, she was a bit firmer going over that very end bit. Nothing in it. Doesn't get any better than that. So that is how you cut a precise Acme, or in this case trapezoidal thread, by tackling each part, all 4 parts individually. Your OD, your ID, your flanks, and then of course mingle all that into your pitch diameter and you'll get a perfect thread every time. Perfect save too. Okay, let's get this. Yeah, I've got a bit of other turning work to do on this, and I'll probably do that off camera. So, quick check over wires. Our specification, the minimum is 29.09. The maximum is 29.39. And we are 29.255. Spot on, right in specification. To check end play, I have to mount it on a thing here so the screw doesn't. As you can see, it's free there. Like that's in a free position there. I put the spacer under there with my finger on it, so there's no twisting. We're only getting a pure up and down to check the end play. Barely perceptible, 0.01 millimeter. So we can use the old Jones and Lamson 18-inch optical comparator to have a bit of a bo peep at our thread, and yeah, just to have a bit of a look, see how we did. We know we're on pitch diameter, we know we have a good fit, but it's interesting, I find it is, to actually see your thread close up. So we've got good root radius down the bottom there, and we haven't broken the edges of our crest radiuses. There is supposed to be a little radius on the crest. We've yet to do that, and I haven't done it yet because it makes it hard to get any sort of proper measurements in the comparator when you know everything's sort of, the radiuses are in place. So we can check our thread angle first. So if you can faintly see that line down there, which is the line on my screen, that's set at 15 degrees, which is half of our thread angle. So if I jigger across, so we're looking really good there. Okay, we'll check the other side. I've just reset the, hang on. Should be, okay, that line's set on 15 degrees there. Same line. You can see we're right on it. So we know our angle is bang on. So we can check our crest width and our root width. So we're on approximately, nearest as I can get it, to the corner of our thread there. So that's 0.5, 1 millimeter, 1.83 is our target, 1.5, 1.6, 1.7, 1.75. So we're probably about 0.4, 1.83 is there. We'll bring it back. So we're probably 0.4, 0.5, probably 1.5 thou. I think that's converts. Yeah, probably about 1.5 thou shy, skinny on our crest width, which is fine. The thread is still falling, you know, into a good tolerance. So we'll have a look at our root. Now the root width will come up skinnier depending on how deep you've taken your cut, you know. 1.83 is the ideal, but I know that we will come up short of that. So it's 0.5, 1, 1.5, 1.6, 1. Probably 1.7. There's 1.7 millimeters there. So yeah, that's quite normal for that to come up shallow. So if we're able to measure this diameter here, or our true supposed root diameter, you know, the further you come up, the wider that gets quite quickly. Our root radiuses look good. I'm unable to measure them at the moment, but yeah, something to work on in the future. So we were looking on 20 times magnification. This here is on 10 times magnification. But yeah, it's a great tool for checking things like this. So we have our part cut to length now. It's faced off and nice and smooth on the end. This is my hardness tester. So I'll do three drops. 26.3 HRC, 27.1, 27. So that's an average on the 3 drops of 26. Oops, where are we? Might see that. 26.8 HRC. So yeah, it's not. It's equivalent. It's pre-hard 4140. That's as supplied. You know, pre-hard is as supplied. Before we haven't hardened yet. It's not annealed 4140. So it's not cheese steel. You know, free cutting steel. At all. So all right, and the cut quality come up very good. This is the leading edge of the thread, which is the easy one to do, and the trailing edge, which is the difficult one out of the two, and that come up very well as well. So we're looking at the trailing edge further down. This is down near the end. I've already done the keyway in it. Yeah, that's that bit where that tool grabbed. Well, one of the bits where the tool grabbed. So that didn't clean up, but at least it's only on 2 threads. And the other bit where it grabbed, I'll zoom, try and find it. Just down in the root of that thread there was the other grab. I'll just add in the couple of times where the tool grabbed and created these dramas that we were having. It was all on times. I didn't film every single pass with the tool and all of the cutting. So, you know, otherwise it'd be a 6-hour long video. So, but yeah, it all happened, unfortunately, yeah, on when I had the camera turned off. So I haven't edited them out, and I actually went through to make sure, because I would have preferred them to be in so you could see that. Yeah, it was just, unfortunately, that's how it rolls, and nothing I can do about it. Yeah, they just never got filmed, but you got to see the aftermath and how we got round it. So. Alright, well, as you've seen, not too shabby a result, came out very well. So that's just another alternate method for cutting an Acme, or in this case trapezoidal thread. Acme and trapezoidal, just one's the inch version, one's the metric version, and 1 degree difference in the thread angle, you know. So yeah, so that's just a different way of doing it, using multiple tools. And that way you get full control over your sides, your flanks, leading, trailing, your root. You've got everything at, you know, full control. Plus, you know, you don't always, a one-off thing like this, you don't really want to go and buy an expensive insert. And if we had done that, in the case of this, well, it would have broken. It wouldn't not have survived at all. The tool steel we were using was Chicago Latrobe Cobalt, so that's quite a, you know, that's not a shabby bit of tool steel, and even that, you know, as you've seen, it knocked the edge clean off that as well. So, but the material 4140, it's never the friendliest material to screw cut, especially a long thing like this. This is 500 millimeters of thread, you know, so but we got through it relatively unscathed, you know. Yeah, it did. I did have to pull quite a few, well, use my full experience of what I know to be able to get through that with it, you know, successfully. So anyway, hope you got something out of it. The best thing I could recommend is don't do it, because what my normal course is something like this. I would just go and buy a length of trapezoidal rod. The only reason I didn't with this is because in the rest of the machining on this part, there is a knob on the end, you know, it's sort of where it steps up. But I mean, I could have got around that just a different way. So anyway, I thought I'd cut my own. So cheers, thanks for watching, and yeah, hopefully see you in the next video. Cheers.